inside a compacted sand mold. 700-degree molten aluminum begins to solidify. This small plug may not look like much, but on a freshly cast cylinder head, it plays a critical role. The valve seats and valves must line up perfectly. That precision is what makes a reliable engine. A skilled worker clears the surface with compressed air. Once these parts are finished, this factory in Anhui can turn out first-class engine parts. Let us take a closer look. To make an aluminum engine cylinder head, the process starts with a special sand mixture. The sand is packed into the mold across the entire work area. The shape already looks highly detailed, but loose sand alone cannot withstand the casting process. So next, steel pins press down from above. In just a few seconds, a pile of loose sand becomes a solid mold core. In casting, material quality matters a lot. Some sand is chosen for strength, and some for surface finish. For engine parts, even tiny differences matter. The grains must be consistent, because every detail affects the final casting. No shortcuts here. Once resin is added to the sand, the cores are strong enough for the next stage. Then the aluminum ingots arrive and are loaded toward the furnace, where they will be melted down. The sand cores used here are extremely accurate. Across the four corners, the tolerance is under 0.1 millimeters. They feel surprisingly solid and give the mold the support it needs. The core is then locked into position. To be exact, 2 main cores are enough for one cylinder head. It may look heavy and solid from the outside, but the inside is full of carefully planned passages for air, fuel, oil, and moving parts. Once molten aluminum is poured in, the mold cannot be allowed to shake. Even this clean turning angle is controlled by a hydraulic push rod. A quality cylinder head depends on carefully timed cooling, and that usually takes at least 30 minutes. To keep the line moving, the casting is transferred onto a work table. As the heat slowly fades, the cylinder head cools back down. Then it is ready for the next step, removing the sand inside, because the sand core is now trapped inside the aluminum casting. You cannot just pull it out by hand. That would be impossible. So the part is vibrated to shake loose the sand from every direction. At this point, the cylinder head is not perfectly clean yet, but it is ready to be handled and moved to the cutting stage. The excess top section is cut away with a saw. To keep the cut smooth, the worker sprays cutting fluid on both sides. Once the extra material is removed, you can see the casting is not one solid block. The factory groups these parts in batches of 50, then adjusts the equipment carefully before heat treating them at a stable temperature. This treatment strengthens the aluminum and prepares it for precision machining. After that, the surface still needs finishing. Tiny steel shot, smaller than a millimeter, is blasted at high speed. That is why the machine is fully enclosed, to protect workers from flying particles. The cylinder head comes out looking clean and bright, but the surface is still not ready for valves and camshafts. A manual cleaning pass is still absolutely necessary. Fortunately, low-frequency vibration removes many impurities. The worker then uses a brush to clear the loose material below before the part can pass inspection. There's still a lot of work left. As the process moves forward, there are fewer manual steps. But even with automation, checking the precision is a step that cannot be skipped. They first check the machined surface, then use a gauge to verify flatness. Why not rely on a camera alone? Because inside a cylinder head, some areas require more precise tools. Take the valve and camshaft channels. Most of that machining happens here, with so many internal holes. This stage takes serious time. Once the cutting fluid stops dripping, the worker moves the part to a side rack. Then the visual inspection begins. The cylinder head sits on top of the engine block. All those small circular openings can make the part look complicated. The worker's job is to inspect the polished surface closely and make sure everything is correct. The reflective edges on both sides are checked repeatedly during production. But under that clean-looking surface, there may still be hidden moisture. Without a narrow air tube, it would be very hard to clean properly. The outer edges of the cylinder head also need to meet the standard. During this step, the worker may use a pointed tool or a small grinding wheel to clean up rough edges by hand. That small touch makes a difference. It is more important than it looks. Not every hole in the cylinder head stays open. Some of them must be sealed with plugs. The red material applied here is sealant, similar to thread locker used on fasteners. So how do they confirm the seal is good? How do they know the plugs will not leak? They test it with high-pressure air. If no bubbles appear during the test, the seal passes inspection. In fact, over the years, the plugs installed by these workers have had an excellent leak-free record. After the part is lifted out of the test tank, the valve seats on both sides are installed. These cannot simply be hammered into place. Instead, the factory uses a controlled hydraulic press with the pressure calculated precisely. There is little room for error. But one thing still needs attention, and that is the final seat positions left by machining. Both the inner diameter and surface height must be inspected carefully. After all this machining, the cylinder head is much lighter than before. Once installed in the engine, that reduced weight helps improve overall efficiency. The valve stem seals are pressed in next. Doing this one by one avoids problems later. Then the valves are assembled as quickly as possible, because for a complete cylinder head, there are still strong valve springs and valve keepers waiting to go in. People outside the industry may not realize it, but without the right tools, this job is physically demanding. A proper tool keeps the small parts locked in place, so the engine can deliver reliable power. Next, the worker installs the camshaft. An experienced technician adds lubricant to the grooves first. This is where the camshaft will sit. Then it is carefully snapped into place. At this point, no extra adjustment is needed, because from here, there are still more parts to install. The same air gun and the same routine happen every day to make sure every unit meets the standard. A retaining ring is added at the end. During shipping, this part must be protected carefully. Over long distances, bumps and vibration are unavoidable. Without proper packaging, damage could easily occur. That is why the workshop uses multiple layers of inner and outer protection. So whether it travels overseas or sits in storage, it arrives ready to install.